Okay, good morning, Professor David J. De Los Reyes. Okay, my discussion for this long video format will be, this is advanced mathematics, this is Laplace Transform, okay? So we go away first with those taking up the SAT and the CAT. We'll go with the advanced mathematics, okay? The given problem is, we are given a function of S. This will be a problem under advanced mathematics, and the subtopic is actually Laplace transform. We are given function of s equal to 3s minus 1 over s squared plus 9. Find function of t equal to. Under Laplace transform, what is given as an equation is actually in terms of as a function of s. And the problem is asking for the given function as a function of t. Because under the so-called study of differential equation, we could bring out the solution of this by using the conventional solution differential equation, but there is another type of mathematics, and that is Laplace transform. So we are given this function of s. So by using Laplace transform, we are asked to find for a function of t in what will be equal to. Okay, let's proceed with the solution. Function of this is a small letter f as a function of s equal to 3s minus 1 all over s squared plus 9. Okay. Rewriting the left hand side, and for the right hand side, we use algebraic manipulation. Okay, under the so-called solution Laplace transform, we will use just simple algebraic manipulation, and we could bring out the solution of function of t in what will be equal to. We will not use differential equation because the inventor of this Laplace make a table in which if we arrive at a certain function, we could go back and we will find the solution of the required problem. Okay, for the right hand side, the numerator is actually a difference, right? A 3s minus 1. And this is 1 under 1 common denominator. So the right hand side, by using algebraic manipulation, that is algebra, right? That is an A plus B over C. This is now algebra. I am just recalling what we did on the right. This can be written as A over C plus B over C. Because if we try to compress this one under one common denominator, it will be A plus B. But if we try to expand this one, it can be written as A over C plus B over C. So what we did here, we segregate this 3s and this minus 1 under same common denominator. We could do that by using this concept. So the right hand side can be written as 3s over s squared plus 9 minus, this is now minus. Okay? The overall sign of the second fraction will now be minus because this minus. This minus 1 over s squared plus 9. Okay? And again, by using algebraic manipulation, okay, it can be written as 3, open bracket, s will remain inside. I bring out this 3, right? Anyway, the operation on the numerator is multiplication. 3 times s is actually 3s. So this 3 here can be, we could bring it out, right? So this is 3, open bracket, s over s squared. 9 can be written as 3 square close bracket minus, okay, 1/3 times open bracket 3 over s square plus 3 quantity square close bracket. Why did I introduce this 3 here? because from the previous step, there was no 3. Okay, actually, I could place 3 here. Okay, and to neutralize that the effect of the 1 placing the 3, I will place 1/3. Because if we try to bring out this one, if we try to bring out this 3, a 1/3 times 3, this is actually 1. So, actually, we didn't change the value, right? So, again, I will place 3 here, but I must have to place 1/3 outside. So, I didn't change the problem. It's just like in the integration. If you put something on the total integral, okay, to counteract that total integral and you will not change the value, you place a reciprocal value outside. So I place 3 here, and to offset the effect of this, I must have to place 1/3 because 1/3 times 3 is actually 1. So it is just same as this one. Okay? So actually this portion is algebraic manipulation. This is all algebra. Right? Then to bring out the solution now, we will take the inverse Laplace transform of both sides. The inverse Laplace. Laplace transform is like that. The inverse Laplace is actually with the -1. Okay? So I place it here. Take the inverse Laplace transform of both sides, meaning the left and right. So I place it here. The inverse Laplace transform of small letter f as a function of s should be equal to, this is 3, right? We could bring it out from the Laplace, inverse Laplace. It's just like in the integration. So this can be written as 3, the inverse Laplace of s over s squared plus 3 squared close bracket minus 1/3, the inverse Laplace of 3 over s squared plus 3 squared close bracket. So all constant actually is outside the inverse Laplace, and it is outside. And if we try to recall the table about this portion here, okay, it's actually this one. And this portion here is actually this one. No, the first one is this one. The one with the s is this one. And the one with the 3 over here is actually this one. Because on the table of the Laplace transform, the person who invented this Laplace transform, he formulated these equations here. So if we arrive at this, to bring out the solution, you just go back. That's why we take the inverse Laplace. So if we go back, we are now solving that function of s as a function of t. So if we try to, what you call this, compare this one, this is s over s squared plus omega squared. According to Mr. Laplace, the solution for that will be cosine of omega t. And the second one, this 3 here is a pure constant, that's actually omega. This omega over s squared plus omega squared is actually, the equivalent of this is actually sine of omega t. Okay? So, because we arrive at this one already, and this is one, so the solution of this two will be this two here. Okay? The inverse Laplace transform of function of s will now be function of t, and this should be equal to 3. S over s squared plus 3 squared is actually this one here. It is cosine of 3t, where omega is actually 3, right? The first one is cosine of 3t, and the second one will be sine of 3t. So the required function of t from the given function of s is actually 3 cosine of 3t minus 1/3 sine of 3t. That's it. That's Laplace transform. It's an advanced mathematics topic, right? Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.